Newton's second law. Remember from earlier in the year when we talked about acceleration, it described how quickly the motion changes. Now we're going to talk about what changes the acceleration, like what causes the acceleration. Newton's second law states that the acceleration produced by a net force on an object is, first of all, directly proportional to the magnitude of the net force. That means if one goes up, the other goes up. So if the acceleration increases, so does the force. Also, it's in the same direction as the net force. And it's inversely proportional to the mass of the object. Remember that inversely proportional means that if one goes up, the other goes down. So if the acceleration goes up, so the mass goes down. Push on an empty shopping cart, then push equally hard on a heavily loaded shopping cart. The loaded shopping cart will accelerate much less than the empty cart. This shows that acceleration depends on the mass being pushed. The same force applied to twice as much mass results in only half the acceleration. For 3 times the mass, 1/3 the acceleration results. That's because mass resists acceleration. The equation for Newton's second law is A equals F divided by m, where A is acceleration and the unit is meters per second squared. F is force in newtons, and m is mass in kilograms. The first example says what acceleration is produced by a force of 2,000 newtons applied to a 1,000 kilogram car. So first we draw a diagram. And this car is 1,000 kilograms. And we apply a force of 2,000 newtons. Okay, so our equation, acceleration, is force divided by mass. So when we plug in our values, acceleration is 2,000 divided by 1,000, which gives us 2. Now, since it's an acceleration, our unit is 2 meters per second. The second example says if this car is towing another car of equal mass, what acceleration can it attain? So if we draw another diagram of a car towing a car, so now we have 1,000 kilograms here and 1,000 kilograms here. So we've doubled the mass. The same force of 2,000 newtons is there. Acceleration is force divided by mass. So it's 2,000 divided by 2,000, which is 1 meter per second squared. Now, does that make sense? If you double the mass, you cut the acceleration in half. The force of friction between surfaces depends on the kinds of material in contact and how much the surfaces are pressed together. Look at this cross-section view of a concrete road divider and a steel road divider. Which design is best for slowing an out-of-control side-swiping car? This side is the concrete, because the friction between the tire and the concrete are more effective in slowing a car than the friction of the steel car body and the steel car rail. Also notice the shape. The concrete barrier is wider at the bottom, which increases the amount of pressure between the tire and the barrier.